So in this video, we'll look at the meaning of finding absolute maximum values and absolute minimum values of a function f of x in an interval a to b. And the meaning is actually quite easy to understand. You just have to find the maximum and minimum values of the functions inside certain interval for the x. I mean, x has to be sitting inside the interval a and b. A to B basically. So now instead of going to the calculation directly, let's look at the picture and please think about the meaning of absolute max and absolute mean more carefully. So please look at the current picture. For the graph y equals f of x. And let's say if I just focus myself on looking at the values of x between a and b, something like that, which means I only look at the line, the purple line for the graph of y equals f of x inside the interval a to b. Now, absolute maximum is which point? Absolute maximum now occurs right around here, right? But basically, this point is the highest value that you can achieve. For the graph from a to b, x equals a to x equals b, inside this interval, this is the highest value. So this value is called absolute maximum. And let's look at the lowest possible value you can get, which is this point, right? I think this one is the absolute minimum value that you can obtain right here. So please think about this graph. I mean, I hope this graph actually illustrates the fact that, you see, the note is that absolute max or absolute mean can occur at the boundary point, which is either A or B. In this case, x equals B will give you the absolute maximum in this current problem. But of course, in other possibilities, there's a chance that in the boundary point, you can get absolute minimum also, right? So now, how about this one? You see, you actually achieve the absolute minimum at this point. And this point is what we call local minimum in the last video when we discussed about these critical numbers. And it means what? It means sometimes the absolute max or mean can actually occur at the critical numbers. As we have discussed in the last video, critical numbers x basically means f prime, the derivative equals 0 or f prime is undefined. And in this case, when you have a point local minimum, the f prime is actually 0, you see, because the slope is actually 0 for the horizontal tangent. And now let's look at more calculations. Please look at the current problem now. I'm giving you a function f of x, and the x is inside the interval 1 to 5. And let's take a look at how you can find the absolute maximum and absolute minimum values of f. First of all, please note that based on my previous picture, the absolute max and mean can occur at the boundary points or maybe at other critical numbers of x. And it means what? It means that as a first step, at the step 1, you can find the boundary values first. So boundary values means you have to evaluate f at the point 1, which is the left boundary point, and the f of 5, which is the right boundary point. And please do it by calculator, and for f of 1, it's the same as -6, and for f of 5, it's the same as 26. And now, keep these two values with you. You need to find the critical numbers and critical values of a function f. And to find the critical numbers, please recall you need to find the derivative first. And the derivative of this function is 6x squared minus 18x, right? In this case, we can set it 0 to find the critical numbers. And please solve it yourself. You can do a factorization if you want. And actually, the fact is that you have two critical points, is 0 or 3, after solving these equations. And now you have two critical numbers. And corresponding to each number, you need to evaluate the function f at these two values to get the critical values. So please do these two calculations now. And but instead of getting f of 0, can you see why you actually don't need these values? Because you see x equals 0 is not in the interval 1 to 5. Because at the beginning, I told you that all the values should be between the boundary 1 and 5. And the boundary points, the boundary values are obtained at the first two lines in this page, and which means we don't have to find f of 0. We can directly go to f of 3, minus 26. And now we have one critical value we care about for x equals 3 in the interval 1 to 5, and we have two boundary points. As a final stage, please compare all the values you have in 1, 2, and 3. Please compare them. The absolute maximum is exactly the maximum value among the three values you compare, and the maximum is actually 26. It occurs at the right endpoint, which is x equals 5. And the absolute minimum is actually at critical value, which is minus 26. It occurs when x is at point number 3. So that's the end to this problem. Please look at this current problem where f is given as x plus 1 over x, and x needs to sit in the interval from 0.5 to 3. And same thing here. To find the absolute maximum values and minimum values, as a step 1, you need to compute the boundary values. So it means that you need to evaluate f at these 2 points, 0.5 and 3. So when x is at 0.5, you need to evaluate this. And the value is 2.5. It is the first point you look at. For the right endpoint, which is x equals 3, the value is 3 plus 1 over 3, which is 10 over 3. It is the second point. So you have two boundary points here. And the second thing is to check whether you have some critical numbers and also the corresponding critical values. So to find the critical point, we need to find f prime for the function f, and f prime now is the same as 1 because the derivative of x becomes 1. And the second term, the derivative is minus 1 over x squared. And that's the derivative you can get. And let's set it 0 and find the corresponding critical number. So now please solve the equation yourself. For x squared equals 1, you see x is either plus 1 or minus 1. But if you look at this point, x equals minus 1, we don't need it because it's not the interval 0.5 to 3, right? I mean, minus 1 is out of the interval, so it's not something we care about. So in that case, it means we have only one critical number. And then we can evaluate the f at the critical number x equals 1. So the value is 2. Now, please compare all the three values you have here. The first two values are the boundary values, and the last one is the critical value at the critical number 1. And I think now it's quite clear. The absolute maximum is actually at the right endpoint, which is 10 over 3. And the absolute minimum is actually the value 2, which occurs at the critical number x equals 1. And that's basically the end to this problem.